Thank you very much. Okay, first of all, I would like to thank the organizers for this opportunity. I'm a physicist by training, working with economics, so I will try to fit somehow in this Open Universe initiative, and I will try to give you an idea of which is our approach to big data and what one could learn out of this approach, using this approach about the impact of astrophysics on various issues. And in general, when one deals with economic big data and analysis, one has this kind of situation. This is, for instance, a book about industrialization of African countries. You come up with 200 pages of economic indicators as a function of time, and in order to get a conclusion out of this, you need an expert that is able to read the plot, and each expert come out with his favorite indicator, and then he pick a conclusion, for instance, and this country is going to exit from the poverty trap in a given amount of years. Our approach is to try to extract from data with suitable analysis something that is more in the direction of a scientific argument. That is, for instance, here you can see that if you, I don't know if this, okay. Here you can see, for instance, a plot of GDP per capita and fitness, that is this measure of economic complexity that we introduced. And out of this, one will say, okay, Kenya and Senegal are the most probable, in our opinion, countries to exit from the poverty trap. So this is something that can be tested, and it is, in our opinion, more in a scientific perspective. One can do also some more quantitative analysis. This is more or less the same plane, and the blue band here means that you have an increase of input of GDP growth due to input. That is, you are exit from the poverty trap and you are going to catch up with the other developed countries. And here we prove that this kind of approach is able to tell you which is the right dimension to look at when you have to lower your threshold in order to be able to exit from the poverty trap. So, which is our big data? Our big data is threefold. We have the export of countries, so which physical products are recorded by customs when they flow from one country to another. We have the patenting activity, that is the technological codes that are written inside the patents that are submitted by a firm, and scientific activity, that is the production and the citation of articles in journals, proceedings, and so on. So astrophysics is here. So out of this, we did, well, this kind of situation can be represented in this way, I would say. There is a multi-layer space of development in which technologies are connected to countries if these countries has a comparative advantage in these technologies, and countries are also connected to product. So what we want to measure is the information flow in this multi-layered network. Of course, you can substitute this layer with the layer of science, and astrophysics will be one of these nodes. So this is a little bit technical, so I will go quite fast here, but the point is that we come out with a matrix that is country and science. If a country has a real comparative advantage in one science, a country product matrix, that is if a country makes a product, and a country technology matrix if a country makes has a patenting activity that is that gives a comparative advantage with respect to the other countries. So in these cases, these are binary matrices, and they can be 0 or 1 if there is a comparative advantage. So out of this, one can make a projection. That is, you fix 2 layers, and out of these 2 layers, you can compute which is the information flow, we can say, the correlation that can be possibly time delayed from one layer to another layer, and the first thing that we did, for instance, is to make the projection from the layer of products to the layer of products. So we came out with something like this. That is, this is a network of products. That is, each node is a product, and 2 products are connected at first approximation if a lot of countries are doing both. So most of the capabilities that are needed to be able to produce 2 close products are present in the same countries, are the same. So, for instance, here you can see the situation of Sweden, and green dots mean that Sweden is exporting that products, and red dots is that they are not exporting that product. So our recommendation would be to go and do this product here, because this product is close and is and can be reached it is feasible from this point of view. We also applied this kind of approach to study the industrialization industrialization process of countries. They follow this network in a coherent way. But now let's consider all the layers of this network, and here you can see this projection with in which we take into account all the 3 layers. That is, the scientific categories in yellow, the technological categories, and the industrial sectors that are blue. So, for instance, here you can see that physics and astronomy is very core. So it is a hub that has a lot of connection not only with other scientific fields, but also with industrial and technological fields. Planetary science is a little less connected. I will say it is in the periphery here, but it's interesting because it is connected to mining. That is a technological code, so it means patenting activity in mining, and in mineral, that is an industrial sector. So it has this kind of spillovers. Here the links are selected by having a statistical significance with respect to the randomization of the input matrices. Now let's go to astrophysics. So as starting nodes, here we put these Scopus codes that are astronomy and astrophysics. That is this one, and another code that is space and planetary science. So with respect to the previous figure that I show you, Here we are at a less aggregated level from the point of view of the technological codes, of the scientific codes, sorry. But we are still at a very aggregated level from the point of view of the technological codes. And here you can see which is the effect of having a comparative advantage in terms of scientific production in astrophysics. So countries that have this advantage with respect to the other countries in astrophysics usually have, in this case with a time delay of 5 years, a technological patenting activity in separating and instruments. Here we have a lot of technological codes that are inside instruments. Here we have time instruments to measure time, space, optics. So what we did is also to have a look at what happens when you open these categories and you consider the subcategories, and the technological codes that are associated as an output of astrophysics are, for instance, these ones. You can see earth drilling, chemical and physical processes, for instance, catalysis, data processing systems, also non-positive displacement pumps that are used to empty, to get things empty, and many more that I don't have the time and the space to show. So as a some final comments. I've tried to give you an idea of what is our approach to big data, and I've shown you 2 applications. One is to trade data, so the network of products, and the other application is this multi-layer, so products, technologies, and science all together. With respect to the Open University Initiative, I would say that it will hopefully produce an increase of scientific production in astrophysics. And as I've tried to show you, this will trigger a cascade of feedbacks in other fields that are not scientific, but for instance, technological. So an increase in the patenting activities in these technological codes that I've shown you. I really hope that this initiative will be extended also to economic databases in which there is really an issue with respect to the data transparency, to have an open database with respect to these kind of issues will be really, really good for all the field. And finally, our experience from working with economic data is that having coherent databases is really important and should hopefully be addressed, because really a lot of mistakes come out from the very fact that people are calling the same things with different names. And so, in my opinion, this should be a question that should be definitely addressed. Thank you for your attention.
Thank you, Andrea. And thank you very much for this presentation, because we understand we are pioneering, you are developing, is a new technique, is far from being consolidated yet in the astrophysics field, but it reminds me a lot of the discussion I had with my scientist colleagues, and when we try to enter in the minefield of economy and the economic benefits, they always claim, but we are not here for economy, we are here for curiosity-driven science, but here you are opening up an interesting avenue. So I'm wondering whether there are questions from the audience. I see already one, please.
Very nice paper. I like your approach.
Can you introduce, please, yourself?
I'm sorry. I'm Pepi Fabiano from Harvard Smithsonian, and I'm the chair of the IVOA. I'm an astrophysicist, X-ray astronomy, and I like working with data. But the question, definitely there is a correlation between astrophysics, science, and industry, whatever. But that doesn't mean it's a causation. Could go the other way around. Is there any way to demonstrate that?
Of course, everything that I've shown you, I would. It would be been better to specify it. Maybe it is everything. Everything I show you is about correlation and not causation. So it is, of course, not very easy to put the system in the very same situation and to make some kind of controlled experiment. What we are showing is that there is, however, a time-delayed correlation. So this means that you can make a Granger non-causality test out of this, in order to go more in the causality direction. And also we are studying the asymmetries. That is, on average, what we see is that the flow is in both directions when you consider different, that is, positive and negative time lags. You have but these correlations are very long in time, and there are some asymmetries. For instance, astrophysics is very asymmetric from this point of view, meaning that if you make the transpose of these, you will see different technologies that are needed to improve one country advantage in astrophysics. So we are still working on this, and for instance, this is not published, and but you are perfectly right when you address this causality versus correlation issue.
Any other question there? Yeah.
Grazie. So, Laura Gatti from Thales Alenia Space. I would like just to complement what Mr. Zaccaria said and also Delfina said at the beginning, on the fact that open data is something that is can really give an advantage not only to, let's say, different kind of industry, I mean oil and gas and others, but also for the space system development industry. Here I can say, for instance, 3 examples to demonstrate that. For instance, when we are setting up a new mission in space, it's very useful for us to have data from past missions in order to better shape the architecture of the next one. Another example is that we need as much as possible data from scientific experiments in space when we have to, for instance, characterize at best some regions of the universe in which we want to place our satellites, for instance, in the Lagrangian points. The third example is the fact that through scientific data from space, we are able also to study and to promote some innovation. For instance, in the field of electronic components. Just to give you a concrete example of that, we made in the recent past a study correlating and analyzing the Gaia focal plane data with other auxiliary data, and also with some sun effects, in order to characterize the behavior of electronic components that are subjected to radiation field damages. And so this is something that bring an advantage to industry, to the space system developers, and also to the scientists, because in the next mission they will can have systems that are more reliable and better for their research. So also space industry can benefit of scientific data, not only other kind of industry. This is my comment.
Thank you, Laura, and I think it's very relevant. So we have another.
Yes, of course.
Another question.
Okay.
Another question.
We have another question out there.
Andy Pollock, University of Sheffield in England, astrophysicist. Is there any data that you would have liked to be available that was not, that would have helped you advance these extremely interesting correlations or causes that you're showing us?
Well, it is not an easy question. I have to think about it. Well, I will say that in general, one of the most important problems here is that the industrial production of countries, you can see what is the industrial production of countries only when physical objects pass through customs. So the problem here is to reconcile, to make a reconciliation among all the industrial production of all countries, and most importantly on services. So my dream-like database would have not only the export but also the production and also services in a homogeneous way. So recorded the same for all countries. This is, I would say, impossible, but this is an answer to your question.
Good. Okay, we stop here because we are